Okay, from today onwards, I'm going to solve Striver's SDE sheet. I like that sheet. I actually don't like it by the way, but it is pretty much important to solve the Striver's SDE sheet because in my previous interview at Garmin, I got questioned a similar question that is directly from Striver's SDE sheet. So I understood the importance of it and I'm thinking to do it. And first of all, I'm going to focus on the topics arrays, strings, linked list, bind search, heaps, queues, stacks. And for now, I'm thinking to stop focusing on trees, graphs, and DP because those topics are currently out of my reach for the companies around 15 LPA right now. So for my on-campus placements, I'm thinking of completing Strivers SDE sheet in a span of like 10 days, like on 9th August. So this is what I'm going to do, and I would explain. I mean, basically, I won't explain anything. I would actually see the question and see the approach and understand how it is being solved, and then I'll solve it on my own. And this is what I'm gonna do. Basically, this is, you may ask why, because I'm in a learning stage and I will learn. And after learning this, I will again solve them once more so that the concept get reinforced in my brain. And later on, when I see a similar problem, I can actually do it quick in the interview. And this is what I'm thinking of. Yeah, so let's proceed with the first one, which is set matrix 0. So coming to set matrix 0, what this question is. This question states that you're given an 2D array given an element to an integer matrix. If an element is 0, set its entire row and column zeros. You must do it in place. Okay, so if something is 0, its rows and columns should be 0. Okay, so coming here, we understood the problem. So let's see the approaches that we have. The brute force approach is to use two for loops, and whenever we spot a 0, if any cell ij containing the value 0, we'll mark all the cells in the row I and the column j with -1 except those which contain 0. So we'll mark all the cells which are non-zero as -1 where a 0 is present. So the I rows and j columns. Row I and column j. We will perform step 2 for every cell containing O. Finally, we will mark all the cells containing -1 with 0. Thus, the given matrix will be modified according to the question. Not here we are assuming the matrix does not contain any negative numbers, but if it contains negatives, we need to find some other ways to mark the cells instead of making them -1. Okay, that sounds fair because if there is a negative number and if we mark it -1, then obviously it's totally uh, booked. So coming here, so what are the steps that we're gonna follow? If any cell contains something 0, the row I, everything except the 0 is marked as -1, which contains 0. So we'll mark all cells in row I and column J with minus. We will perform step 2 for every cell containing 0. Finally, we'll mark all cells containing -1 with 0. Great. So let's go on. So for suppose this is thing, here we found a 0. So what we're gonna do is we're gonna mark this -1, -1, -1, and this will be 0. And this will be -1. Again after this, we'll convert all the -1 into 0. That's what we're gonna do. Okay, so let us do that. Let's go here. For int I equals 0, I less than matrix of 0 dot, no, it is first matrix dot length I this for int j equals 0, j less than matrix of 0 dot length, the length of the first row, j plus plus, and then we have I will definitely we need to see whether if the row is 0 or not. So, if the element is 0 or not. If matrix of I j equals 0, we mark the rows and columns with -1. Mm, okay. What are we gonna do? We're gonna do -1, right? Else all the cells else. But I think this will be big of n cube, no? Oh, but this is big. That is why it is brute force. Okay, let's check the code here, what it is. Okay, what it is. See, matrix is if it is not equals to 0, then we're just marking it minus 1. So, if matrix of ij not equals to 0, what are you doing? We're marking it minus 1. Matrix of I. This doesn't seem fair. I mean, array list, you took an array list. Set all non-zero elements is minus 1 in the row I. Uh, Macro, okay. He just defined two functions first, macro, mark column, and then he's calling these two whenever he found something zero. And then finally he's marking else. So this is kind of a shitty thing to do. It won't work, I guess, because what are the constraints here? The constraints are 2 power minus 31. Okay, the constraints are good, but I guess doing a brute force solutions won't work. Let's go for the better one. The better one using the previous approach, we are making the row in the column minus 1 while traversing the matrix. Here we will reduce the time complexity by marking the cells after the traversal. So how do we gonna do it? Approach using two extra arrays. Steps are as follows. First, we'll declare two arrays, a row array of size n and a column array of size m, and both are initialized with 0. Then, we'll use two loops, nested loops, to traverse all cells of the matrix. If any cell I, j contains the value 0, then we will mark the index of the row array, that is row of I, and jth index of the call array, call of j, as 1. Okay. It signifies that all elements in the ith row and jth column will be 0 in the final matrix. We'll perform step 3 for every cell containing 0. Okay. Finally, we will again traverse the entire matrix and will put 0 into all the cells ij for which either row I and call j is marked as 1. Thus, we get a final matrix. Okay. Understood the logic? I'll try to write the code. Okay. First of all, just give this. Okay, we'll declare two arrays. Int uh, int row int row equals to new int of matrix dot length. Next, int all equals to new int of matrix of 0 dot length. And then since we got two, what we're gonna do is if matrix of I comma j equals 0, then we're gonna mark we're going to do two functionalities here. First one would include make row of I equals to 0, sorry, equals to 1, and call of j equals to 1. Okay, so now we got two things done. Again, time to make the non-zero rows zeros. Okay, making non-zero elements 0. So again, basically the same code. I'll write it here. If row of I equals to 1 or call of j equals to 1, basically you're done, buddy. That element will be 0. Matrix of I j will become 0, and that's it. So this is how the matrix will be. Run this code. Yeah, it is accepted. Let's see how it works. Okay, it's actually accepted, but there is an issue with the space complexity. The time complexity will be m into n, since we're using two for loops or marking. But let us check. how can we reduce the space complexity? Here is where we're going to use the optimal approach, where in the previous approach, the time complexity is minimal, as the traversal of the matrix is at least, that is n into m, where n equals rows, m equals columns. Okay, in this approach, we can just improve the space complexity. So instead of using two extra matrices, row and col, we can use the first row and the first column of the given matrix to keep track of the cells that we need to mark with. But here comes the problem. If we try to use the first row and the first column to serve this purpose, the cell matrix 0, 0 is taken twice. Yeah, that's an issue. So, to solve this problem, we'll take an extra variable called 0, initialized with 1. Now, the entire first row of the matrix will serve the purpose of the row array. Okay, and the entire first column. Okay, instead of taking two arrays, since it's a 2D matrix, we have taken the first row as the row array and the first column as a column array. But the issue arises when, uh, what we say? The first row, sorry, the first cell, which is 0, 0, is taken. It is taken two times in the first row and then in the first column. So instead of that, we're going to use a variable to track this. Okay. So what are we gonna do? If matrix of I j equals 0, then we're going to do matrix of I. So if the specific value is 0, we're going to do this, and matrix of J, and I would be 0 here. So this is what we have done. And then if matrix of matrix of I equals 0, I 0 equals to 1, or matrix of 0, J equals to 1, we're going to write it as 0. Actually, I haven't taken the first variable part. Let's check. Yeah, it is wrong. So let's check the code. What happened? Where did I get wrong? Code. Okay. Okay, we're taking this one. Contains matrix of get I get J. Get I set 0, 0. If matrix of J not equals to 0. Actually, he's used an array list, but he's using the matrix. Okay. Anyway, that's okay. Okay. If J not equals 0, then matrix of, okay. If I dot J get J, matrix dot get I dot get J equals 0. Matrix of get I set 0, comma 0. Okay. There's something I'm not getting my mind down. Okay. Complexity is, okay. I don't get this. I'll just leave this. The previous code is pretty good. I'll just go with it. Why to do something complex if you can do this easily? Okay. Matrix of I j equals 0. Mhm. Okay, done. So one question is done. Next comes another question. Pascal's triangle. I don't even know what this question is. Let's read. Okay. The Pascal's triangle. In the Pascal's triangle, given an integer, written the first numbers of Pascal's triangle. In Pascal's triangle, each number is the sum of two numbers directly above. So basically, we need to print an output here, the Pascal triangle result. So if an integer numbers is given, we need to return the number of rows available. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, like that. So basically, this is what we need to print. And no, I don't know the approach. Let's check again. No issues. The thing is to learn. Learning makes us good. So let's check this. Problem statement. The problem has three variations. They are stated below. Given row number R and column number C, print the element at a position in the Pascal triangle. Variation 2. Given the row number N, print nth row of the Pascal triangle. And variation 3. Given number of rows N, print the first n rows of the Pascal triangle. In Pascal's triangle, given number is the sum of the two numbers. Okay, this shit we know it. Okay, variation 1. So how he's gonna do it? In this case, okay, first we'll see the variation 3, which is what we know. The naive approach is basically combination of variation. Okay. So we definitely should go with variation 1 and 2. So in this case, we are given the row number R and the column number C, and we need to find out element at position R, comma C. Naive approaches in this case, we're given the row number and the column number, and we need to find out the element at position so and so. Then, one of the naive approaches is to generate the entire Pascal triangle and then find the element at position R, comma C. So, generating entire sequence and then figuring out the certain element with the certain index. We will discuss in the variation 3 how to generate Pascal triangle. We will have an easier formula to find out the element. Okay, this sounds great. So to find out the element, that is R minus 1, C minus 1, this is actually combinations. Let's try to analyze the formula to find the value of the combination, assuming R minus 1 as n and C minus 1 as R. And CR equals n factorial by R factorial into R minus n minus R factorial. This is the common formula that you must know. Okay, calculating the value of NCR. We'll separately calculate. Okay, this basically is something we should know. We can separately calculate n factorial, r factorial. Okay. We can calculate the factorials here. We can optimize this calculation with the following observation. Mm-mm-mm. Now n equals to r minus 1, 7 1 6, r is equals to c minus 1. Here's 3. Let's calculate 63. This will boil down to 6 into 5 into 4 by 3 into 2 into 1. Okay, this basically is NCF formula, nothing else. So n into n minus 1 into n minus r plus 1. Why? So I will use the optimized formula. Mm-hmm. Hmm. Into n minus 1. Okay, we got the thing. I understood that any position is basically the formula here. And r, so it is NCR formula where r minus 1, c minus 1. It's the formula here. Okay, chill out, bro. This is what you got. You got this. This is easy. Simple, cool. Next, variation 2. What does it say? Given the row number n, print nth row of Pascal triangle. Now we're going to the game. So we need to print the nth row of the Pascal triangle. The naive approach is for every column from 1 to n, we'll calculate the element where n is the given row number and c is the column number. Okay, basically scaling up the given formula. Like at each element we know it. So we'll use the for loop, we'll calculate the factorial. I mean, not the factorial, the combination, and then we'll just print it. Okay, this can be done. This is good actually. This approach for every column from 1 to n, we'll calculate approach. Okay. This is cool. Optimal approach. We'll try to put the intuition for the optimal approach. The following observations. 5 into 4 by 1 into 2 into by 2 10. 5 into 4 into 3 by 1 into 2. Hmm. Here we can observe that the numbers marked as red are added to the previous number. In each step, the numerator is multiplied by the previous consecutive element and the denominator is multiplied by the next consecutive element. We'll replicate this in our algorithm. First, we need to mark the indices of the column starting from 0. Then, we simply multiply the numerator by an index, the denominator by the index itself. Okay, and equals to previous element into row number minus column number index. Okay, code. Buddy, this is big. Iteration 3 goes. Drive approach. First, we run a loop from 1 to n. We will use a loop, say column, to iterate or each column. And inside the nested loops, we'll do the following steps. First, we'll consider row as n, column as 1 as r. After that, we'll simply calculate the value of the combination using a loop. The loop will run from 0 to r, and in each iteration, we'll multiply n minus I with the result and divide the result by I plus 1. Okay. When we'll add the element to the temporary list. So calculating all the elements from the columns of a row, we will add the temporary list to a final answer list. Finally, we will return the answer list. Okay. Sounds big, but it's just a combination of a lot of problems. Nothing much of a big deal because it's not actually how we see the Pascal triangle, but the approach here is pretty much different. Because in any of the Pascal triangle sums, the position actually here is described as different. It's totally different. Here, if I understand the logic, I should write the code on my own, but I feel it's pretty not not great actually. I'm thinking I'm understanding it, but it's pretty much difficult. Now, in the optimal approach of variation 2, we have learned how to generate a row and time complexity. So, in order to optimize the overall time complexity, we will use the approach for every row. Thus, the time complexity will reduce. So basically, I'll try to understand the code first. Okay, let it look good. List integer answer equals to list. Okay, this is what we need to add. Inserting question meant list answer dot add one. Calculate the rest of the elements. For int call equals to one, call equals to row, call plus plus, answer equals to answer into row minus call. Equals to answer by call, answer dot add. So this basically adds the elements. Return answer to. Okay, this is actually generating a row. Next, for public Pascal triangle, void main list integer new array list for int I row equals to 1, row less than equals to n, row plus plus answer dot add generate row, return ans. We are going to just print this sheet. Okay, this is pretty easy. Basically, the thing is we need to have a generator basically. So first of all, we're going to create an array list of array lists. So list of list of integers. Solution equals to okay, we'll make it as ans equals to new array list. Sounds fun, right? Next, for int I equals to 0. No, not I equals 0, I equals to 1. I less than num rows basically. Um, rows I plus plus. Uh, what do you say basically? Add row. Add. So ans dot add add row of I. Okay. So basically we're going to write this public list of integer now integer. Okay, this is enough. add row. Okay, we'll write generate row, that will suit better. Generate, we'll copy this. Generate row int n. So here is the approach. Since we have seen it, basically we'll take a variable answer int ans. Let's check this. I don't remember much. So ans equals to 1. The first of here, since the first row should be 1. Hmm. I mean every element in the first of the Pascal triangle is 1. Then list integer ans row equals to new array list. We're going to create a list. Int ans equals to 1. List integer ans row equals to new array list. Okay, now we're using for loop for int I equals to 1. Oh, yeah, I less than n I plus plus ans into equals to I, ans by equals to I, right? Mhm. Okay, okay. There's something I need to know. Call I less than row I plus plus, there is n here. Ans dot add. Okay. Hmm. Adding things is required. So dot add one. Okay, first element is added here. And then in the for loop, first of all, we understand that ans equals to ans into row minus column, because the current row and current column value is required. Okay. Okay. Add int ans into row minus column. This basically is a formula that we need to remember. Minus I. Answer y equals to I. Oh, no. I guess it's right. Hmm. Answers dot row ans row dot add int. Basically, we need to add the result, this ans. So after adding this, we'll get a row, and then that's what we're gonna return, right? So return ans row. Is it that? Okay, and we're returning it. That's it. Let's see. Okay, basically we haven't returned it. Return ans. Mhm. Uh, it's assigned first. Yep. Done, buddy. That's great. The time complex is big of and into row into column. And here, what we're gonna use is the main logic lies here. Basically, the row minus column. This main logic is what the key to this problem. The heart of the logic is this. Where it is. Oh man, where did it went? This one. So the current answer into the row minus 1 by column minus 1, row minus column by column. 5 into 0 minus 1 minus 0 by 1, which is 5. Oh, okay. Okay, first one is 5. Okay. Next answer to 20 by 10, right? Which is, sorry, 20 by 2. 5 into 4. 1, 2, 3. 1, 2, 3, 4, 5. Hmm. It's first minus 1. Man, I don't get this right. Observe that the numbers multiplied or added to the previous number to build the current number. Current element is equals to previous element into row number minus column index by column index. Okay, this is a formula. I don't know how it came, but it came. Okay. Mm, anyways, it works. So it's done. I've done two questions. It's 11:44. I have 15 more minutes. Mm, this is completed. Okay, set matrix 0 is done. Square triangle is done. And the next permutation. Now it's kind of shitty question, but I don't have any option. I need to do this. Mm, okay. For example, array 1, 2, 3, the following of the permutations 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Okay, that's great. Next permutation of an array is the next lexicographically greater permutation of its integer. Formally, if all permutations of an array are sorted in a container to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted order. If such sorted arrangement is not possible, the array must be rearranged as the lowest possible order, that is sorted in ascending order. Okay, so 1, 2, 3 will be 1, 3, 2, and 2, 3, 1 would be 3, 1, 2, and 3, 2, 1 would be 1, 2, 3 because after 3 to 1 we don't have any largest number that is possible. So given an array of nums, find the next permutation, and this should be done in place. Man, literally I don't know this. I don't know how to solve this, but I guess I can learn this. Let's learn this. Okay. Given an array of integers, rearrange the numbers of the given array into like so. Okay, we actually know this. Basically, we're gonna generate the permutations, add it into a 2D array or an array list, and then sort it and find the position. We can do this, but this will be the brute force solution that I'm thinking of. Let's check. Finding all possible permutations. So this is the brute force approach. And you know what? The thing is, I don't even know how to write the brute force, find all possible permutations. Okay, so basically he's saying we need to watch this. Let's check. Man, I
So
hate it.
let's check it out how we are going to do this. So assume this is the array that we are working with and the size of this is 3. So initially when you start off, you will be having a pointer over here, right at 1. First step that we are going to do is we are going to try everyone at the first this position, that is the 0th
Man, I'm feeling sleepy. Mm,
index. We're going to try everyone at the 0th index. So what we do is we swap 1 with 1. Remember this. We swap 1 with 1. So it makes sure that this 1 is at the first position. If you did not understand this, you will please stay with me a bit. So I swap this 1 with 1. So I'm making sure that this 1 is taking the first position.
I'm feeling sleepy because hmm, first things first, this is a topic that I don't know, and moreover, I hate to do. Okay, so if my count is 2 today, I don't like this anyway. But Okay. Anyway, I need to do this. I'll do just this and I'll go. That's it.
Position. And after that, I will move this pointer to 2. Okay. Stay with me, you will understand.
Okay.
The next step that I will do is I'll try to have this 2. Yes, I'll try to have this 2 at the starting position. So what I will do is I'll tell swap 1 to 2. Yes. So this 1 gets swapped to 2. So
Hmm.
you will have 2, 1, 3.
Okay.
Now the other thing that I can do is I can have this 3 at the starting position. So I will say swap 1 to 3. So when I swap 1 to 3, I will have 3 at the starting.
Buddy, I understand. I can't do this. Ah, shit, man. I need to jot only two questions today, and I hate this question. But the thing is, it's one of the most important questions that I ask with multiple companies, and I fail to do this. This is not gonna end well. The question and backtracking are the key parts that I need to master, and I'm not mastering them. Okay, I know this is shit. Hmm. Okay, let's go for another question. Cadence algorithm. So this is something that I do well. Hmm. Find a subarray with the largest sum and return its sum. So solve this or solve it again. So I feel that I have done something today. And start equals 0, int and equals 0. Oh, okay. For int I equals to 0, I less than start length I plus plus. Uh, okay, we need to find the sum, largest sum, right? We don't need to find the array. Shell dude int max sum equals 0. So now sum plus equals to nums of I, and if sum is less than 0 means that this is not gonna work. So we're gonna do start equals to I. Uh, and then we also need to make sure for the sum is uh, max sum equals to math dot max of max sum comma sum. It's a max sum. I don't think this will work. Int. Okay, I better declare it before. Mhm. I don't know what I did. I just asked ChatGPT because she's what it has couple of bugs. Incorrect initialization, maximum should be initialized instead of analysis. Might say, yeah, one logic for the start reset. Resetting statical star is not useful if you're not using it. Correct. Yeah, that's the mistake I did. Okay, if you don't know something, you better learn it rather than bragging that you know it. This is something I did wrong. And then we initialize sums to 0. Sum plus equals nums away, right? Sum less than equals 0. We're gonna make sum equals to 0. It's not start. Okay. What we're gonna maximize is the sum. Initially we took sum 0, sum equals num5. Sum is became negative, then we should sum it becomes into right. So maximum equals to max dot max of maximum comes sum. Okay. Mm, okay. July 16th and it's 25th. Okay, 9 days. I just forgot the logic. That's it. No worries. I can do this. Nauseous. Cadence algorithm. Hey, bud. Here's something I did. I did it like this. N big of n, but this is a dumb approach. We're gonna do it optimally. We're gonna use that Dutch natural flag algorithm. Hmm. Okay, stock buy and zero this. Okay, the next permutation and these three sums are the sums that actually are the quality sums for me today. And not these two, by the way. Mm, but anyways, I'm happy with what I got. Mm. What's the better approach? Keeping count of values. That's shit. A better use optimal approach, which is just natural flag algorithm. Hmm. Uh, bro, my butt is aching because I sit for a long time. Anyways, so first, don't see the code, see the logic. You'll get it, buddy. The problem is the variation of popular Dutch natural flag algorithm. The algorithm contains three pointers: low, mid, and high. Three main rules. Rules are the following. If array of 0 to low minus 1 contains zeros, extreme left part. Array of low to mid minus 1 contains ones, and array of high to and minus 1 contains twos, extreme right part. Okay, the middle part. So basically, we're going to take three pointers: array of low, array of mid, array of high. So initialize low and mid at the starting, high at the ending. Okay, I think I got a logic. Um, I'll just say refactor the code. Yeah, int low, comma mid equals to 0, int high equals to nums dot length minus 1. Okay, for int I equals to 0, I less than nums of I, nums dot length. Okay, that seems feasible. Nums dot length I plus plus. Yeah, if what are you gonna do? If nums of I equals 0, basically, if nums of I equals 0, what we're gonna do is we're gonna update the uh, low point, right? So nums nums of I, not nums of I. We just need to make sure that all the elements before the low pointer are 0. So if we figure out some element as 0, suppose uh, 0, 1, 0, 2, 0, 1, 2. Okay, we just figure out a zero. That's great. If a zero is found, we just push it past. We update the what do we say basically? We just swap the current element wherever. For suppose we find zero here. Okay, here is low, here is high, and now no low and mid are there. We just found zero, and next we found one. Okay, so we just position midpoint to one. And then again we found a zero. We just update the low pointer and swap these two things. So it will become 0, 0, 1, 2, 0, 1, 2. And now basically we have low here, mid here, and then we found, okay, we just found a 1. So if a 1 is found, we just mark it mid. And then we found a 2. We just need to swap the high. We just need to update the high and swap it. So this will become 0, 0, 1, 1, 0, 2, 2. And high will be here. Low will be here. Mid will be in this place. And then comes the low pointer again when we find a 1. So when we find a 1, that means that the mid pointer should be updated. No, no need to update. No, I'm not getting the logic here. I'm missing something. Let's check what we left. Okay. In our case, we can assume that the entire given array is unsorted, so we'll place the pointers accordingly. For example, if an array is given as so-and-so, the array of three pointers will look like the following. Low and mid in the same first position and high at the last position. Here, as the entire array is unsorted, we have placed the mid pointer in the first index and the higher pointer in the last index. The low is also pointing to the first index, and we also have no other index before 0. Here, we are mostly interested in placing the mid pointer and the high pointer as they represent the unsorted part in the hypothetical array. Okay, this is great. Okay, so basically the game is all about mid and high pointers. Now let's understand how the pointers will work to make the array sorted approach. Here in the tutorial, we will work based on the value of the mid pointer. Steps will be the following. First, we'll run a loop that will continue until mid is less than or equals to high end. That makes sense because middle should be less than or equals to high end. After that, the loop should fail. There can be three different values of mid pointer. That is, area of mid can be 0, it can be 1, or it can be 2. And if area of mid is 0, it means that that belongs to the low pointer level. So we'll swap area of low with area of mid and we will increment both low and mid. Okay, that's great. Now the subarray from the index 0 to low minus 1 will contain only zeros. If array of mid equals to 1, we'll just increment the midpoint and then the index mid minus 1 will point to the last to the 1 as it according to the roots. Array of mid equals to, we swap the array of mid with the array of high and then we'll decrement high. Now the subarray from the index high plus min to n minus 1 will only contains 2. And this step, so after swapping something up, we'll just increment the values or decrement the values based on the low or the high pointer that's available. So that makes sense. Okay, so we're gonna use a while loop because we don't know how many times it's gonna be done. So while mid less than equals to high. Oh God, high. What we're gonna do is if nums of mid is equals to 0. It means that we figured out a 0. So we're gonna use int temp equals to, okay, we're gonna use a swap function. Basically, that will help us a lot. Um, Public void swap um, int nums, comma, int a, comma, int b. So basically, int temp equals to nums of a and nums of a equals to nums of b. Nums of b is equals to temp. That's it. Swapping is done. So what we're gonna do is we're gonna use swap, and what we're gonna do? We're gonna use nums, mid, and low, and then we're gonna do mid plus plus low plus plus. Since we are incrementing the points. And next, if we figure out that nums of mid equals 2, so we do, sorry, if it is equals to 1, we do nothing but we just update the midpoint. If nums of mid it's just else if, and this would suffice with else, I guess. Else, um, swap nums, comma, mid, comma, high, high, then mid plus plus, high, high, right? High minus minus. Okay, basically, I did the swapping thing. I guess this should work. But there is something you just missed, which is updating the midpointer for every iteration. Yeah, hope this works. Low might have not been initialized. I think we did int low. Okay, this won't work in Java, right? Equals 0, mid equals 0. I don't know what actually happened, but 201 102. Okay, I did the wrong swapping. We should swap low with mid, and we should swap high with mid. I think it works now. Still no. Oh my God. Okay, something I missed. Let's ask ChatGPT. Oh yeah, I am a shit. I understood. I am a shit because the updation is being done normally in the conditions. Why would I require to update middle pointer again? Got it now. And again, I did something wrong. I don't get it. Why? 102 120. It failed at test case 120. Why, bro? Why? Okay. And also swap high mid. You should increment mid after swapping with high because the swapped value. You should not increment mid. Okay. Maybe 0 or 1 needs to be processed again. Okay, this is meant that I did not understand the logic here. Hmm. Yes, I understood now. But let us understand what's happening here clearly. If num equals 0, that is, if we found a Cheeto, we swap this, and we're going to we are swapping this because we need to make sure that all the zeros are behind low marker. Okay, and then we're updating the mid. So from low to mid we contain ones. And then if we find a 2, okay, if we find something 2, okay, what happens if array of mid is 2? That means that we just swap the mid and we just reduce high. Why not? We should not increment mid after swapping with high because the swapped value from high might be 0 or 1 and needs to be processed again. Okay, that's the main issue here. Hmm. Okay, anyways, this worked. Yeah, next, it's time to buy and sell stocks, I guess. We can do this. Mm-mm-mm-mm-mm. This is simply cadence all go, buddy. I think I can do this. Int by equals to basically the first one, which is prices on day one, you're gonna buy it. Int profit equals to integer. Why can't we just integer? Okay, integer dot min underscore value. We just need to maximize this guy, this buddy, max profit. Okay, for int I equals 0, I less than prices dot length I plus plus. So if we figure out int profit equals to nums of, oh sorry, it is prices, right? Prices of I minus what it does, it is actually by. So we're just gonna see this, and now if we're just gonna compare the profit first, max profit equals to math dot max of max profit comma profit. Okay, next comes the way where if what is it? If profit is negative, it means that we need to change the buying price. So buy equals I. That's it, buddy. So I think I'm done here. Return return max profit. Okay, I just yeah, max profit. Again, capital M A max profit. Oh, why did I kept I? I just prices of I. Yeah, I did it. I did it. And why I did it? Because this is the thing. I got failed 14 times before answering this. So that is why I understood this. Hmm. Okay. So basically, I did 5 questions today. I'd be happy of doing another one. Next presentation, but not today, buddy. I'm training. So if I don't feel good, it's better that I actually revise. Because anyway, I would be productive if I revise. And that's great. Today I did 5 questions. I'm gonna jot it down. And that's it. Thank you. Bye. Good night. Hey, buddy, I need to stop recording. Okay, I'll just use it here.